When I first tried this question, I made the mistake of starting to add lots of lengths on, like calling this X and calling this Y and things like that, but not taking into account the regular hexagon. Like it was never going to work. I don't know why I did it. You got to sometimes just pause a moment before you dive into the question and just think, how can we use all the information that we're given? And the regular hexagon really, it just makes it all come together. It's absolutely essential. So what I'm going to do is I am going to call this X, and then I'm going to try and write down other lengths in terms of X. And if I drop perpendiculars down like this, then now we'll use the fact that we've got a regular hexagon. Um, in a regular hexagon, the angles are all 120. So this angle up here is 120, and this one is going to be 60, and this is 90. And what I've actually created, if I put these two together, is an equilateral triangle. And what I'm trying to say is that this length is a half p, and this length is also a half p. You could also work it out using trigonometry if you don't spot this in equilateral triangle, because we know this is p, we can use sine 60. No, not sine 60, cos 60 is this length divided by p, and that ends up being a half p. So what I'm trying to say is that this length is going to be x plus p, because I've got a half p to the left of this part and a half p to the right of this part. So I can write down a first equation that we're told that the 5 sections have the same perimeter. So let's call the perimeter L, not P, because I've already used a P. And for this top shape, L is actually going to be x plus p, those are the two horizontal lengths, plus p plus p, so 2p, and therefore it's going to be 2x plus 3p. Okay, let's move on to the next one. This is going to work in a very similar way actually. Now I've constructed this idea because this is going to be x plus p, but then I'm going to be adding q on because again, this little region is an equilateral triangle. So I've got a half p here, sorry, not p, a half q here, and a half q here. So the length is going to be x plus p, the top length, plus x plus p plus q, the bottom horizontal length, plus 2q. So overall, 2x plus 2p plus 3q. And actually at this point, I'm gonna take a look at equaling them. I can write down that 2x plus 3p equals 2x plus 2p plus 3q. Cancel out the two x's, minus 2p from both sides, so p is going to equal 3q. Yeah, just put a little box around that, because remember, we're interested in the ratio, so we just found out that p has to be 3 times as much as q. Okay, let's keep going for this final shape, because the ones below we've already dealt with, they're going to be equivalent to the blue and the red, but this purple one, I'm going to have, actually this length is also going to be x plus p plus q, and therefore the length is going to be 2 lots of x plus p plus q, 2 horizontal lengths, and then I've got r, and another 2 r's, so 4r. Therefore I have 2x plus 2p plus 2q plus 4r. And what shall I do? Let's relate the blue and the purple together, I think. So it must be that 2x plus 3p is equal to 2x plus 2p plus 2q plus 4r. Again, cancel out the two x's, minus 2p from both sides, and then I'm going to use the fact that p is equal to 3q. So 3q is equal to 2q plus 4r, meaning that q is 4r. All right, and this is brilliant now. So I'm trying to write p to, I think it's p to q to r. Let me just check. Yeah, the ratios of the lengths p, q, and r. Well, that means in that order, p to q to r. So I have that p is equal to 3q, and I have that q is equal to 4r. So if I substitute in 4r into here, I actually get 12r. So it's going to be 12r to 4r to r, which can then be simplified to 12 to 4 to 1. That is going to be our final answer. Okay, big fan of this question. Really makes you think about it. I hope you're happy with it as well. Well done.